Hey everyone, in this video we will discuss a number theory problem. The question is, prove that n minus 1 whole square plus n square plus n plus 1 whole square is not a perfect square. So we have n minus 1 whole square plus n square plus n plus 1 whole square. Now in other words, we have taken sum of 3 consecutive perfect squares, right? 3 consecutive perfect squares. So we are saying that if we take 3 consecutive numbers and if we add their squares, then there is no way that this is going to be a perfect square. So this is not a perfect square. So that's what we have to prove. So let's solve this. We have n minus 1 whole square plus n square plus n plus 1 whole square. Now if we open this, then we will get n square minus 2n plus 1 plus n square plus n square. If you open this, then you will get n square plus 2n plus 1. Now if we add, now first thing, these two will get cancelled out, right? So you will get 3n square 1 2 3 plus 1 plus 1 2. So we got 3n square plus 2. When we simplified this expression, we got 3n square plus 2. Now we will use a very important property of number theory, and I'm not sure whether you are aware of this or not, but you should be. You should always remember this. So whenever we take a square, this is always congruent to 0 or 1 modulo 3. Actually this is not true only for 3, this is true for 2, 3 and 4. So whenever you take any square and you divide it by either 2 or 3 or 4, you are always going to get a remainder of 0 or 1 only. Now for 2 this would be true obviously, because for 2 you are not going to get any remainder other than 0 and 1. But for 3 and 4 you should remember, if you divide by 3, then you are going to get a remainder of 0 or 1. If you divide by 4, you are again going to get a remainder of 0 and 1 only. And that is the property that we will use here, right? So we have this expression 3n square plus 2. When you divide this by 3, when you take mod 3 on this, so this is divisible by 3, this portion is divisible by 3, but this is my remainder, so you get a remainder of 2. But my property says that a square is congruent to 0 or 1 modulo 3, right? If you have a perfect square, then it must give you remainder of 0 or 1 only, not 2 when you divide by 3. But we just saw that this expression is giving me a remainder of 2 when I divide by 3. So it means that this expression can never be a perfect square. Not a perfect square. Right? In other words, this expression that was originally given in the question, this expression n minus 1 whole square plus n square plus n plus 1 whole square can never be a perfect square, and this was our proof, right? So this is proof. Now in words we say that if you take 3 consecutive numbers and if you add their squares, then those can never be a perfect square. So that is what it is in the words. So let's meet in some other video. We will discuss some more such questions. Thank you.